Hi everyone! By the end of this video, you should be able to solve log equations. And there are really only two steps you need to know to be able to do that. First, you want to always make sure you simplify the equation, and then all you have to do is rewrite the equation in exponential form. Any problem with a star, I'm going to leave for you to do. So I'm actually going to start with number 2. So first you want to see if you can simplify this. Now, just like any other equation, you always want to go in reverse PEMDAS. So you want to start with addition or subtraction, then multiply or divide, and then you can go all the way to exponents, which the log is inverse of an exponent. So first thing I'm going to do is subtract the 7 from both sides to get rid of that and get the log alone. So I'll have negative log base 3 of x plus 1 equals negative 5. Okay, now there's a negative in front of the log, which is really like a negative 1, if you imagine that. So I'll divide both sides by negative 1 to get rid of that. And that will leave you with log base 3 of x plus 1 equals 5. Once you have the log isolated, all you have to do is rewrite in exponential form. So think about how we do that. The base of the log is the same as the base of the exponent. Now, logs solve for exponents. So the output of a log is always the exponent. So it's 3 to the 5th, and then your argument becomes the output, equals x plus 1. So then you can just calculate this out. 3 to the 5th is 243, and that equals x plus 1. Subtract 1 from both sides, you'll get x equals 242. Okay, so that's what I mean by simplifying and rewriting. Now, sometimes you may have to do a little bit more simplifying in terms of like not just subtracting and whatnot. Like you may have to apply some log properties to simplify. So the rule is if you have two separate logs, I can condense them into one log. And the less logs you have in a problem, the more likely you are to be able to solve it. So instead of writing these as log of this plus log of that, the rule when you add, you can multiply the arguments to condense them. So this is actually log base 2 of x minus 3 times x minus 5 equals log base 2 of 3. Anytime you see a problem with more than one log on the same side, you're going to want to see if you can use log properties to condense. Okay, so I'd always check for not only addition, subtraction, division, whatever it is, I'd check and see, can I apply any log properties to simplify this? Okay, so thinking about this actual problem, these are both log base of 2. So if you think about this, if I have log base 2 of x equals log base 2 of y, in order for these to be the same or to be equal, all that would have to happen is that x equals y. If the arguments are the same and you take the log of them, then it's going to be an equivalent equation. So here, all that has to happen is that x minus 3 times x minus 5 has to equal 3. If the arguments are the same and you take the log of them, then the whole equation is going to be equal. So in some cases, you don't actually have to rewrite an exponential. If there's log on both sides, you can actually just think about it, and it's a little bit easier. Now, if I multiply this out, I'll get a quadratic, so you will have to solve quadratics in some of these problems. So applying everything that you have learned this year. So x times x gives me x squared. My outers give me minus 5x, my inners give me minus 3x. So combining those, that gives me minus 8x. And my last give me plus 15, and that equals 3. Okay, in order to solve a quadratic, I want to get it set equal to 0 so I can use the zero product property, or I can use a quadratic formula. So this is x squared minus 8x plus 12 equals 0. So now you want to see if you can factor that. If you can't factor that, you can try using the quadratic formula. Think about what you can do there. So I'm going to try and factor this. I have x times x give me x squared. What multiplies to 12 and adds to 8, but it's got to be negative 8. So it's got to be minus 6 and minus 2, and that one is factorable. So you get x equals 6 or x equals 2. Now my favorite part about solving equations is you can always check and make sure you got 100%. So if you plug these back in, let's say you plug in 2. I'll get log base 2 of 2 minus 3, which is log base 2 of negative 1. Wait a minute, what does that mean? 2 to what power equals negative 1? Is that possible? And the answer is no. So with that said, you can get extraneous solutions in log equations, and you always want to check them. If you plug in 2 here also, you'll have a negative number. So that 2 doesn't work, but if I plug in 6, I will get positive numbers in both of the logs, so that will be okay. Moral of the story, just make sure you always check your solutions. Anytime you plug in a negative to a log, you'll get an extraneous solution. Number 4, I'm going to leave you to do on your own, but I will say, unlike the previous problem, you may have to rewrite this one in exponential form. That's my hint. I'm also going to leave number 1 for you, and I'm going to do this log challenge problem. This is a challenge because you have a log squared, and you cannot, I'm going to emphasize it, cannot bring this 2 out to the front, because this 2 is not the exponent on the argument. The whole log is being raised to the second power. So this is like log base 3 of x times log base 3 of x. You could expand that if you wanted to, but you cannot bring that 2 out. Okay, so please write that down, make a big star, or do what you need to do. I can bring this 2 out though, because this is an exponent on the argument. So this can be written as log base 3 of x, quantity squared, minus 2 times log base 3 of x equals 3. Okay, now if I can't get rid of this 2, I can't use the log property here of like subtraction because, well, there's 2 logs being multiplied, and there's no rule that says if I have 2 logs multiplied, I can do something with those arguments to condense it. So you have to be a little bit creative if you can't use log properties to condense. So this kind of almost looks like a creative quadratic. Like I have something squared, like this gets like x squared, and then I have that term alone, so this is like 2x. So I'm going to want to actually use a u substitution method here. And I'm going to call u log 3 of x. So if I call u log 3 of x, then I have u squared minus 2u equals 3. And now I'm going to actually want to solve this like a factoring problem. So I'm going to bring the 3 over so I can use the zero product property. This is u squared minus 2u minus 3 equals 0. Go ahead and factor that. You get u minus 3 times u plus 1 equals 0, which would make u 3 and negative 1. Okay, remember we weren't talking about u, we were talking about log 3x, or log base 3 of x. So you're always going to want to substitute that back in. So I have log 3 of x equals 3, and log base 3 of x equals negative 1. So if you want to solve this now, it's really asking 3 to third power equals x. So 3 to the third equals x, because the output of a log is always an exponent. And this is 3 to the negative first equals x. So 3 to the third is just 27 equals x. And 3 to the negative first, well, the exponent rule there is that you flip it, quote unquote. That's not precise, but you know what I'm saying. You're going to bring that 3 to the denominator, so it's 1/3. Now if I go back and plug these in, I won't get any negative arguments, so both of them are great solutions. And that is a challenging log problem because you had to use u substitution and factoring. This one's not quite like that, it's a little bit different. Think about your log properties. You actually will be able to condense that one, but I want you to try that on your own. So that's all I have to say about solving log equations. And remember to always look and see if you can simplify and then rewrite in exponential form, or sometimes you don't have to rewrite in exponential form, like this one we talked about. I hope you learned a lot about solving log equations, and please come with questions.